Alright guys, so I'm not here today obviously, so I will be teaching you this lesson through the video. How these videos work, there's going to be about 3 or 4 of them, and I want you just to work through them as if I was teaching it. You can work with a partner, you can wear earphones, you can use your own device, you can use a Chromebook. For whatever reason, if what I'm saying doesn't make sense, you can always go back and rewatch it. So far so right now go ahead and take out lesson 2.e. So pause it, and you can unpause it when you're ready. And so today what we're going to be learning about is deriving the equations y equals mx and y equals mx plus b. I want you to remember, we've been looking at these. All the linear equations we've been looking at have dealt with these two equations. Now I'm going to show you actually how we solve that. So what we're going to do first is we are going to follow A. So please follow along with me. If I'm going too fast, please feel free to stop it. But what it says graph a line on a coordinate plane that goes up through the origin and has a slope of 2, 3. So we're just going to put a little spot right here at the origin, and I'm going to go up 2 and then over 3 for my point right here. And I'm going to draw a line showing that's my linear equation. So it says, does this line describe a proportional relationship? And it says yes. It does, because it goes through the origin. Because the line goes through the origin. Goes through the origin. And now it says choose any point on that line. So here's my line. Here's my little right triangle right here from my rise 2 and my over 3. And I'm just going to put another point here. I have no idea what it is, but I know I went over on my x and I went up on my y. So it's just an ordered pair that I don't know what it is. It's x comma y. And I'm going to draw another right triangle like this. So it's not perfect, but it's my right triangle. And it says redraw and label in the space below. So I'm going to go ahead and label both my triangles in the space below. I have my first one, which is 2 over 3, and my second one, which is x over y. Now I want you to realize that these are proportional triangles. Like we learned on the other one, all I did was dilate it by moving it up, by making it a bigger right triangle. I just don't know the values. It's just x and y. But if you remember, my proportion is 2 over 3, rise over run, which is 2 over 3, and that is going to be equivalent to the ratio of up y over x. And it just looks like this. Okay. So it says write a proportional of ratios, which I just did, and explain why the ratios can be set equal to each other. So they can be set equal to each other. Let's see if that works. No, it will not. So let me scoot back up here. So it works because the slope ratio is constant. And what I mean by that is 2 over 3 is equal to 4 over 6, which is equal to 6 over 9, which is equal to 8 over 12, so on and so forth. Slope ratio is always constant. And the triangles drawn are dilations of each other, and dilations have proportional sides. So dilations have proportional sides. And if you remember, that's just us making things bigger and smaller. Dilations have proportional sides. Proportional sides. Now, if I would like to get, it says solve the equation where you have y by itself. So I want to get y by itself, so all I'm going to do is multiply both sides by x. We looked at this previously. This would give me the equation that y is equal to 2/3 x. Now here it says, where do you see the slope? Now remember, I went up 2 over 3, and we see it, it's the coefficient. It's the 2/3, it's the value in front of x. So we see the slope, in front of the x. It's the coefficient. So right here, that 2/3, that is the slope. And it's the ratio of how much I went up and over. Now, does your equation represent a proportional relationship? So let's go ahead and think about that. Does my slope represent a proportional relationship? And it says yes. The line passes through the origin because the y-intercept is 0, 0. Okay? So it is a proportional relationship because my line goes through the origin. My line goes through the origin. Sorry, my handwriting's so messy. I'm writing on a screen that's upwards and not flat. So, just as a reminder, we just derived the formula y equals mx. And remember, m is the slope. It's the coefficient of x. We did that by making two similar triangles of rise over run, so up 2 over 3. And I set that equivalent to just a mystery point, which is y over x. And I solve for y by just multiplying both sides by x to get y equals 2/3 x. Yay, we derived y equals mx. Let's go ahead and look at this again now. It's going to be a little different. So it says graph a line on the coordinate plane that goes through the origin and has a slope of m. This is saying I have no idea what the slope is, but all I know is it goes through the origin. So here's a straight line. It's going through the origin. I don't know what the slope is. So if I don't know what the slope is, I can just label it, though, how much I went up. Let me choose a color that we'll be able to see. How much I go up and over. Well, remember, it is just how much I go up and over, what my rise over run is. So if how much I go up is m, and how much I go over is 1, I'm going to have a slope of up m over 1, which is just equal to m. Okay, so it's saying I'm going up a mystery amount. I don't know how much it is, and I'm only going over on my x value 1 unit. All right, and it says, does this line describe a proportional relationship? And yes, it does. Yes, because it goes through the origin. Goes through the origin. Now it says choose any point similar like we just did on the graph and label it x and y and draw another right triangle. So before I do that, I'm going to go ahead and do this again where I'm going to draw a right triangle over here. This is going to be m, this is going to be 1. Now I'm going to do it again where I'm going to have x and y. I'm going to draw that triangle again. I have this being my y value and this being my x value. All right. So now it says write a proportional equation on these two values. So remember, they have proportional slopes, they have proportional rise over runs because they are similar triangles. So this would look like rise m over 1, and I'm going to say that's equivalent to rise y over x. And I want to get y by itself, so I'd multiply both sides by x, which of these would cancel, and I would be left with y equals mx. Once again now, without a coefficient, with just the m value, we derive the y equals mx formula. Remember, we're just trying to create a linear equation, and we just derived how we found the equation y equals mx. These will all be straight line equations that go through the origin when they look like y equals mx. And you've seen examples of this before, like y equals 2x, y equals 3x, so on and so forth. Okay? So it says, what is a general equation that represents Ennio proportional relationship? And that's what we just came up with y equals mx. So anytime we have a proportional linear relationship, when it starts from when a line crosses through the origin, we're going to have y equals and then some amount. It could be 3x, it could be 2x, it could be 11x, so on and so forth. All right, so next let's go ahead and look at the second part. So this won't always be the case where we have a linear proportional relationship. We've also looked at ones that have like a start value or initial value. That's when we're adding another problem. So let's go ahead and look at number 3. It says, what about a linear relationship that are not proportional? If the line does not go through the origin, it does not have a constant of proportionality. However, it still has a unit rate. Remember, unit rate is just how much it is increasing by. A translation is another type of transformation that relates to a proportional relationship to a non-proportional relationship. That just means we're going to take our line that goes through the origin and shift it up or shift it down. So shifting a line or moving all the points on one of the lines the same distance in the direction is a translation. For example, if you transform y equals 1/2 x upwards 3 units, every ordered pair that lies on that line will move up 3 units. Algebraically, you add 3 to every y value since it's a vertical shift. So just really quickly, guys, what this means is if I have a line like this, it's going through the origin. If I were to have a vertical shift up 3, that means just each and every one of these points would just go up 3 spots. So I'd have a line that's 3 spots higher than my original one. That's all that is saying. So let's go ahead and look at that together. So if I had the equation y equals 4x, and now I'm going to plug in these x values for each and every one of these values to get my y value. So if I plug in 4, that would be y equals 1/2 of 4, which is 2. Then if 1/2 of 2 is 1, 1/2 of 0 is still just 0, and 1/2 of -1/2 of -2 is just -1. Now that I have these values, I can go ahead and graph them. So if I have 4, 2, that means over 4, up 2. I also have 2 up 1, 0, 0, and -2 down 1. So I want you to notice that I have a linear equation. Do my best to draw a straight line. And that's my first one. So now what we're going to do is on the same coordinate plane, transform every point 3 units up and draw the new graph. So all I'm going to do here now is every time I see one of these points, I'm just going to go up 3. So let's go ahead and get a nice color. And so right here it was 0, 0, so I'm going to have 0 and then up 3. So let's go ahead and take a moment to do that with all the points. As you can see now, I have a line where the line is just 3 spots higher. So looking at D, it says using your table of values, add 3 to every y value. So on my very first equation, when it was y equals 1/2 x, my values when I plugged in these values for x, my y values were 2, 1, 0, -1. Now what we did when we when we did the translation, when we moved it up 3 spots, we just added 3 to all my y values. All the x values stay the same, and my y values increased by 1. So this would give me then 5, 4, 3, and 2. So it says compare the ordered pairs on your new line to those in the table from part D. What do you notice? So when we look at this, when I look at the ordered pair to those table on part D, what we saw is they were the same. Alright, and it says, what is the equation of your new line? How does it compare to y equals 1/2 x? Well, if we notice, y equals 1/2 x, and all I did to change it was I added 3 to each one of my answers. So 3 is added to the y equals 1/2 x. The y-intercept now, instead of going through the origin, my y-intercept is now 0, 3. Remember, your y-intercept is this point. Where does your graph cross the y-axis? So in proportional, it was 0, 0, and on my new blue graph, it was 0, 3. My y-intercept is 3. So let's go ahead and take a pause here and start the next video.